Alright guys, so here we go. Lesson 6.5. Okay, so I told you guys this one's going to be a little tricky. This is called advanced integration techniques, okay, including like inverse trig functions and other stuff. But we're start talking about a bunch of different techniques that we can use to, for example, things like this, okay? I can't do U sub, I can't really split up the fraction. When you guys see something like this, where there's like 3 terms on the top, 2 on the bottom, I don't know, one thing that we can try is long division. Alright, this doesn't come up a ton, but this is just one thing that we can do, so check it out. You guys remember long division when we take that and divide by x squared plus 2. And if you remember about long division, what we do is we take the first 2 terms and we say, okay, how many times does x squared go into x squared? 1 time, right? When I multiply that down, I get x squared plus 2. And then with long division, we change the signs. That cancels, and that cancels actually. Okay, and then we bring this down. Now, if I say, how many times does x squared go into negative 4x? It doesn't. So that is actually my remainder. And if you guys remember from long division, we would write this as 1, so my solution is 1, and a negative 4x remainder. And now that I split that up, I can do this as 2 separate problems. I can do, okay, the integral of 1, and the integral of negative 4x over x squared plus 2. Alright? Well, this first problem, the integral of 1 is x. That's pretty easy. This second one, got to be a little bit more creative here. I need to do u sub. Okay, so I know if u is x squared plus 2, du is 2x dx. Alright? Now what I'm going to do, I have this negative 4. This is how I like to do it. I know some of you guys do it differently. I'll move the negative 4 out and I'm going to put a 2 there because that's what I want, over 2. And what that does is that gives me minus 2 and then the integral of 1 over u du. Okay? So this ends up being x minus 2 ln u, and I can write that as x minus 2 ln x squared plus 2. Okay? So that's one way we can do things. It's something called long division. Another way is, it says we might have to use creative thinking to split the fraction. Let's look over here, you guys. I cannot split this fraction. It's like not letting me do that, you know, because there's 2 terms on the bottom. But look, I'm going to go ahead and try a u sub. Okay? Now the derivative of square root x is 1/2 x to the negative 1/2. I'm going to go ahead and write that as a square root on the bottom. 1 over 2 square root of x dx. Okay? And I got to start subbing in. Well, right here, that turns into u. But then I gotta fix this, and I have this like 1 over 2 square root x dx. But I only wanted to say 1 dx. Okay, so look what I'm going to do. This is going to be a little tricky. Let me solve for dx by multiplying the 2 square root x over here. You guys see that? So it's 2 square root of x du is 1 dx. Okay, I just multiplied this over there. Alright. So I could replace that, my 1 dx right here, 1 dx, I can replace that with 2 square root of x du. And the 2 is definitely allowed to come out front. But I still have an x and a u, right? But look, guys, come back up to here. What is the square root of x? Well, the square root of x, if I add that 1 over, is u plus 1. So, again, leave the 2 out front. U plus 1. And now I'm finally ready to do this integration, okay? Now I can split up the fractions. So I just did a bunch of algebraic manipulation. U over u is 1. 1 over u is 1 over u. And then the integral of 1 is u. The integral of 1 over u is ln u. And if I put my u back in, okay, this is, okay, let's see, this is 2, and then square root of x minus 1 plus ln of square root of x minus 1 plus c. And you could distribute that too if you wanted to. All right, just tons of like manipulations until we can get this thing to be something that we can actually integrate, okay? So those two are tricky. It's like a u sub and a longitudinal kind of tricky, right? Okay. Now, we use mostly arc sine and arc tan. We don't use arc cosine that much because it's just a negative, and we can get it from arc sine. So those are really the two that you want to know. Now, we remember from here, the derivative of arc sine, because if you guys remember, the derivative of arc sine, right, is 1 over the square root of 1 minus x squared. This is just putting it with u's, and it's putting like a du on top. That's for chain rule, okay? And then here's the derivative of arc tan, right? So it's, remember, arc tan of x was just 1 over 1 plus x squared, and then it's just putting that for chain rule. So now we're, integrating both, okay? Let's see, I've written that down earlier. All right, so here we go. This is a good note right here. Since arc sine and arc cosine differ only in signs, it's not necessary to have a third which integrates into arc cosine. We'll just use arc sine all the time. Okay? Now here's how this works. Let's go ahead and take the derivative of this. All right, so we're going back to derivatives for a minute. The derivative of arc sine is 1 over the square root of 1 minus something squared. And the something is whatever I was taking the arc sine of. And then because of chain rule, I do have to multiply by the derivative of that. Actually, I'll just go ahead and put it on the top. So the derivative of that is 1/2. Okay? Now this is good. We want to simplify this a little bit. Let me show you guys something here real quick. Okay, if I square that, that's x squared over 4. Now this is what's called a complex fraction. A complex fraction is when we have a fraction within a bigger fraction. And that's not like typically, simplified all the way. Well, what I want to do is I want to get that fraction out of there, okay? And the way I can do that is I can multiply it by 4 on the inside. All right? Now, because I multiplied by 4 inside a square root, what I really did was I multiplied by 2, because the square root of 4 is 2, which means that I would either have to put a 1/2 on the outside to cancel it, or a 2 over 1, or something like that, okay? To cancel that out, because it's the square root of 4. But the square root of 4 is 2, and if I put 2, then I'm good, right? So what happens is the top, that just goes to 1, and then when I distribute this, it goes to 4 minus x squared. So I want you guys to look at that and that, okay? So what this is kind of showing us is that, okay, so now if I want to go backwards, it's showing us this. If I integrate something, and let's say there's a number instead of a 1 there, let's like call it like an A or whatever. Okay? It is an inverse sine. It is an inverse sine, arc sine, of, but then it's x over a, because 4 was 2 squared, right? So it's x over a, and then that gets us back to here, if that makes sense. So if you want to kind of memorize that, you can really go like, oh gosh, you can do these a lot quicker without a ton of algebraic manipulation. Sort of the same thing works for tangent, okay? So, for example, if I see this, right, I'm going to say, okay, that's the format of an arc sine. But the only difference is I have this right here, right? So how do I fix that? So it's arc sine, and then it's x over a. Okay, x over, and then 2 squared is 4. Okay, makes sense? Okay, guys, so what we're going to do is we're going to look at these, and we're going to see if we can label them like whether they are inverse sine or inverse tan or something like that. Now this is an inverse, well, we'll call it arc actually. You can write like, I guess we can write like this, inverse tan form. That's what we're going to do. Okay? Now, if you remember from up here, all right, if we have an A, a U, and a U prime. Now that U prime is because of the, well, it basically needs to be there when we do U sub, okay? So A squared, U squared is kind of replacing the X and then U prime. So check it out. All right. A is 5, that's that number. U is 2x, so du is 2dx, right? This is normally like what we're doing. We're just putting in this little a right here because of this extra number that we could end up like manipulating to get it out of there, but we're just going to use this, all right? Okay, so if du is 2dx, I need to put in a 2 and a 1/2. And then this turns into, okay, 1/2 the integral of u squared, because it's 2x squared, you guys see that? U squared plus 5, and then it's like du. All right? Well, this is an inverse tan, so we have a 1/2 out front. We can say arctan or inverse tan, it doesn't really matter. And then it's u over a. And then I need to put the u back in, so it's 1/2 arctan 2x over 5 plus c. All right? So if you like kind of memorize this thing with the u's and the a's, and again, you guys, these are mostly going to be multiple choice questions, so you can kind of figure it out. It's going to help you then from having to do like a bunch of algebraic manipulations, you know? Where, okay, so for example, like, let me just show you this real quick. 4x and I think this might be how I learned it. Anyway, so if I've got like 4x squared plus 25, I always learned it where, okay, well that just has to be x squared, so I gotta divide everything on the bottom by 4. So it's x squared, and then it's 25 over 4, but then I also went over 4 to keep it like consistent, you know? And then you take the 1/4 out, and it's like x squared, and then it's 5 over 2 squared. And then, you know, you do all that, and you end up, you get this like 2 over 5 on the inside, you know? I just think that this is like a little bit of an easier way to do it, and so that's the that's how we're going to kind of work on this. Okay, and actually, I forgot one other little thing. Okay, let's look back up here real quick. With arc sine, you can just put the u over a. With arc tan, we've got this u over a, but we also actually have to put 1 over a. And so right here, we also, I neglected to put, so I got u over 5, but I also have to put 1 over 5 right there. So this ends up being 1/10, like that. Okay? This is tricky stuff, guys. Let's try another one. This is tricky. Okay, so first of all, that 8, I don't even need. I'm going to bring that out right now. All right. This is an inverse tan form where A is 3, right? And U is, again, it's just 2x. So du is 2dx. So I need a 2, and then out here I have a 1/2. All right? So this is giving me a 4 on the outside, and then, okay, it turns into du, and then it's 3 plus u squared, right? Now this one is a little bit tricky because, okay, in the press it's giving us like 25, it's giving us 4, it's giving us perfect squares. 3 is not a perfect square. So A is actually, A is not 3, A is square root of 3. That's what A is, so even though it says 3 in here. So it goes like this. So here's my 4, and then it's, okay, arc tan u over a 1 over a. You guys see that? So the 4 just hangs out there. It's arc tan of u over a, and it's 1 over a. So that's from here. Okay? So the a is square root of 3. All right, so that's what I get. Now u was 2x, so let's go ahead and plug that back in. So it's 4 over root 3, and then it's arctan 2x over square root of 3. Now, if I put a plus c, I'm done, except that this problem actually had endpoints. And because I put it back into x's, the endpoints that I'm going to use are the endpoints that were given to me, which is 0 and 1/2. If I had left it in u form, that's fine. I just had to change the 0 and the 1/2. And I would change them over here. 2 times 0 is 0. 2 times 1/2 is 1. So you could, like, honestly, you could do either of those. Okay? And it's going to come out to be the exact same thing. All right? Let's evaluate this at this point. Okay, guys, so here's the fun part. Check it out. This is a constant, right? I'm just going to leave that out front. Okay, and then basically I need to do arctan or inverse tan. I'm going to write inverse tan because I'm running out of room. When I plug in 1/2, 2 times 1/2 is 1. So inverse tan of 1 over root 3. And then I'm going to plug in 0. And I need to do inverse tan of 0. Shoot. What have I did not leave myself enough room. Haha, there we go. Okay. Minus inverse tan of 0. Right? Okay. And now it's like, dude, what? What the heck is this? Now, if this was free response, I'm done because I just evaluated it and I'm cool. It's multiple choice though. You're thinking like, what the heck is inverse tan of 1 over root 3 and what the heck is inverse tan of 0? Okay, you guys, what this means is, this is how you interpret this. You go, the tan of what angle is 1 over root 3? And the tan of what angle is 0? Okay? So if I go back and I look at my trig chart, and I was trying to find the tangent of what is 1 over root 3, and then the tangent of what is 0. Okay, so looking over here, tangent is 1 over root 3 at pi over 6. And tangent 0, okay, it's not over there, I gotta look over here. Tangent is 0 when sine over cosine is 0, which is right here. Alright, at 0. Okay? Now, it also happens right here, but if you guys remember about inverse tan, it only exists in quadrants 1 and 4, so we're not going to use that one. Alright, so we're just going to use this one. So, tangent equals 1 over root 3 at pi over 6. Tangent equals 0 at 0. So, if I come back into here, okay, I get, let's see here, 4 over root 3. That's pi over 6. That's 0. And so my final answer would be like 4 pi over 6 rad 3 or 2 pi over 3 rad 3 if you need to. Whew! Crazy, right guys? That was like a lot. Alright? But that's kind of as like difficult as that gets, I guess. Okay, you guys, check this out. I'm going to say, is this inverse tan form? Well, it looks very similar, before I cross that out, it looks very similar to question 5. See that? There's an 8. But this has an 8x. Guess what? This is not inverse tan form. Okay? It's not. You know what this is? You got to recognize it because of this x right here. Not inverse tan form. This is a regular u sub problem. Okay, so we're going to identify what it is, then we're just going to go do it. U is 3 plus 4x squared. Du, the derivative of that is 8x dx, which is all perfect. So it's like 1 over u du, which is ln u. So this question is ln of 3 plus 4x squared plus c. And it's like one of the easiest questions that we've looked at because it's not an inverse tan or an inverse sine. Okay? Alright. This is also not an inverse tan, not an inverse sine. Remember, an inverse tan is going to be that over that squared plus that squared. And this is just a number, like a constant. Inverse sine is that over the square root of that squared minus that squared. That's inverse tan, that's inverse sine. This does not fit either of those, okay? Can't really split up the fraction, can't really do u sub. So all this, you know what I'm thinking? That the only thing left for me to try, which is usually the one I try last, long division. Okay? So it seems like I'm using that when I have more than one term on the bottom, and if the degree of the top and bottom of this thing. Seems like we go to long division. Let me go ahead and write this as 4x squared plus 3. Okay? So first thing on long division that you do is you say, how many times does 4x squared go into 8x squared? Well, that goes in 2 times. 2 times 4x squared is 8x squared. 2 times 3 is 6. Okay? Then do you guys remember we would change the signs, and I get negative 6, and that's my remainder. Okay? So this problem turns into 2 and a remainder of 6 over the thing we were dividing by. Okay? There we go. Now, we have a new challenge ahead of us, because now we've got, okay, this is the integral of 2, and then 6 over 4x squared plus 2. This is 2dx plus dx. Alright, well, the integral of 2 dx is just 2x. That's fine. But what about this? Is that u sub? This is how I go through my head. Is that u sub? No, because the derivative of 4x squared is 8x, and I don't have that. Is it inverse tan form? I think so, because look, it's got something squared, it's got a number, it's got that. Okay, so I think for this I'm going to do inverse tan form, where the 6 I'm going to bring out front. Okay. Oh wait, that was a plus. Okay, it has to be a plus to the inverse tan form. Okay. A is going to be this, but since it's just a regular 3, it's going to be root 3. U is going to be that, which is 2x squared. Du is 2dx. 2 1/2. My goodness. Okay? So this is going to be 2 dx is du. And this is going to be u squared plus root 3 squared, because that's my A. Alright, let's see if we can get this. Okay, so it's arctan, or inverse tan. It's u over A, and that's 1 over A. And so on my last step, I'm going to go back into x's. So it's arctan of u is 2x plus c. Woo! Guys, this is crazy, right? Okay, cool. I'm just making sure I'm not forgetting anything, and that looks good. Okay. Oh man, dang. Alright. This one is pretty crazy. Okay, you guys. These are like some of the hardest integral questions that you could possibly have, right? So I'm looking at this and I'm like, okay, I can't do u sub. Here's why I can't do u sub. If u is, hang on a sec. If u is 4 minus x squared, du is negative 2x dx, but I can't make that a negative 2 with that plus 4 right there. It doesn't really work. And then I'm looking at this and I'm like, oh, that kind of follows the sine pattern, because inverse sine is like 1 over the square root of something squared minus something squared, like a squared minus u squared. I'm like, kind of looks like that, except the problem is that on the top I have like extra stuff. Okay, guys, this is a, all right, here we go, you ready? Split the fraction, I told you only do that when we have one term on the bottom. Well, we kind of do. I'm going to split it to this. Okay. And then I'm going to split it to this. Right? And then I have two separate problems. Now on this problem, this is a u sum. Because the derivative of 4 minus x squared is 2x, negative 2x dx. That's a u sub. This is an inverse sine form. All right, so now I have two really annoying problems in one problem. It's like, great. Okay, so check it out. You guys are like raw u subs, so let's just do this. That's negative 2x dx, it's negative 2, it's negative 1/2. So this turns into 1 over square root u du. Which if that comes up, it's u to the negative 1/2. So if I add 1, it's u to the 1/2 over 1/2. Okay, so it's negative u to the 1/2. And u is 4 minus x squared. So that's that part, okay? Then I come over here and I have this inverse sine form. Well, the first thing I'm going to do is I'm going to go ahead and bring the 4 out because that's a constant. And I have a is the 4. U is just like, well, I don't even really need to do u. A is 4 and then a is 2 because 2 squared is 4. And then that's just like x squared, right? So x is just x. So this one becomes, I don't know what I've done here. Okay, a 4 on the outside. We don't have to put anything of the a out here. It just becomes a arc sine x over 2 plus c. Because remember on arc sine, we don't have to put that 1 over thing in here. Okay. Alright, let's see if we got that one. Negative. Let's freaking go. Okay. So integration techniques, ridiculous integration techniques. Alright. Completing the square. When you guys were in like, what's it called? Like, well, last year when I taught you completing the square, and it's like, well, I don't need to use completing the square. Completing the square is lame. Alright? And, yeah, I'm with you. Completing the square is lame. Except, check this out, okay? Check this out. Let's complete the square on this. Alright? Half of 4 is 2. 2 squared is 4. If I put a plus 4 in there, I have to put a minus 4 out here. So my complete the square is x plus 2 squared plus 4. Okay? Guess what form this is? This is inverse tan form, where a is 2, because 2 squared is 4. U is x plus 2. Du is dx. Because it's 1 over something squared plus something squared, right? So it becomes an inverse tan form by completing the square. So then it becomes, okay, arctan or inverse tan of u over a 1 over a plus c. Let's go. That one's not too terrible, right? Okay. Alright, last couple real quick here. Okay, this one I am going to go ahead and split up the fraction again. So I'm going to do this one as a single problem over here. So I'm going to do 3 over the square root of 1 minus x squared. And then I'm going to leave the negative with this. I'm going to do this one as a problem over here. Okay? Different colors so you guys can follow me. So I'm going to do negative x over square root of 1 minus x squared. Lazy neutral, put your dx's. Alright. Whew. Now, we've got two separate problems, and over here, that's a u sub problem, and over here, this is an inverse sine form. Okay? If you want to take a second, pause, and see if you guys can do these, I will do that. See how it goes. Okay, so my inverse sine form, first of all, that 3 can come out, right? And then that's actually perfectly set up. I don't got a u or anything. It's 1 over square root of 1 minus x squared. So this is inverse sine. You can write inverse sine or arc sine. You can write whatever you want. X over u plus c. Well, actually, I'm going to put the plus c on the end once I do both of them. Okay, because it's all one big problem. This is now u sub. All right, u sub, let's move over here, is going to go, okay, u is 1 minus x squared, du is negative 2x dx to 1/2. So it's going to be 1/2, 1 over the square root of u du. Okay, the 1/2 from the outside, 1 over square root of du. All right. So this is 1/2. Now, if I bring that up, it's u to the negative 1/2. So it's u to the 1/2, 2 over 1, plus c. Those cross out. Okay, here's my entire final answer. 3 arc sine or inverse sine of x plus u was square root of 1 minus x squared plus c. Okay? All right, last one that we're going to do is really, I mean, this is like one of the trickiest things ever. And I wouldn't even necessarily expect you to be able to just like, it looks like it says tricky. Like, I wouldn't expect you to be able to just like do this. This is really, really difficult, okay? But let's see what we can do here. If I can go like this, and I can take this, and I can say, okay, this is just like crazy manipulation stuff. I don't know, people like mathematicians going, well, I can do it, right? Here's the first method. All right, and if you guys, again, if you wouldn't think of this, but you can at least follow along my steps, that's pretty good. We're going to add we're going to do that. We're going to add an e to the x minus e to the x. You might be sitting there like, what? Why on earth would we do that? Well, I will show you. Now we're going to split it up. The way I'm going to split it up is I'm going to split up that one with that one. Okay? Which 1 plus e to the x over e to the x plus 1 is just 1. And then I'm going to split up that one and that one. All right. Okay, and now I'm going to go ahead and integrate it. This, the integral is just x. This is a u sub, where u is e to the x plus 1, du is e to the x dx, so that minus stays there, and it just ends up being 1 over u du. So it's ln of u. So my final answer is ln e to the x plus, e to the x plus 1 plus c. All right, with an x in the front. So that's definitely one way to do it. Okay, here's another way to do it. Again, algebraic manipulation. Instead of adding something to top and bottom, I'm going to multiply. Okay, e to the negative x on the top and bottom. And I'm going to change this problem into e to the negative x over, now you guys, if I'm multiplying an e to the x and an e to the negative x, that just cancels out and gives me 1. And if I'm multiplying that, that's just e to the negative x. And guess what? Now this is a u sub problem, where I can go, okay, u is 1 plus e to the negative x. du is e to the negative x times negative 1 dx. And so I got a negative and a negative. And then it's 1 over u du. which is going to be negative ln of u, which was 1 plus e to the negative x. Okay? And the point is, these are actually mathematical equivalent. It just doesn't look like it, but they are. Okay? Can't really tell that they are, but they are. I could prove it, but it's gonna, I don't know if it would be worth it. Yeah, it's probably fine. But anyway, those are mathematical equivalents, okay? That was tough. That was a pretty tough section. So we're gonna try to go through some of these next week and see if we can find out if they're arctan, if they're arcsine, if it's long division, complete to square, kind of like crazy stuff. Okay? Anyway, there we go.